now on to some more fun at 5.4. This is factoring simple trinomials. And the reason they're called simple trinomials is for the fact that the a squared term, notice that it's missing the a in front. It's missing the a because we are assuming that a equals 1. For all simple trinomials, a will equal 1. Now, let's go back to before when we were expanding. In the first section, we had to expand this. Whether you did it visually or with the box method or with FOIL, we would get that it is x squared minus 2x minus 15. Again, there could be a few more steps in there. But what if, again, with the factoring, you had to go backwards? If you were given this and you had to go back to the factored form. So this is what we're going to be doing. We're going to be going backwards. Remember that the first one you always want to look for, though, is common factoring. In all these steps, but again, they will only have the x squared term unless there's a common factor you have to do. So some steps, there's a pretty quick shortcut method to when the a value is just 1. And first, the thing you're going to have to do is you're going to have to figure out the patterning. And so when you look at these numbers here, you have to try and figure out how do these numbers relate back to these integers here. Well, it actually works out that the last value, the c value, you're looking for 2 integers that multiply to get this, and those same 2 integers also have to add to get the b term, the value in front of the x. So if you think about this, if we do negative 5 times 3, that gets negative 15, which is what we're looking for. And if you do negative 5 plus 3, that gives you negative 2, which is what we're looking for. So you're looking for 2 integers that are the product or multiply to get c, and add to get the b. Once you have those, you have to do the skeleton, which is, again, just to try and remember it. But this is what your skeleton will look like, or whatever variable that you were using. If it was this, a squared plus 2a minus 5, then this would not be an x, it would be an a. So this is your skeleton, and then once you find your two integers, from step 1, your integers would go in there. So for example, in the last one, the integers were negative 5 and 3, so it would go negative 5 and negative 3, and then you'd have it factored. So it's fairly simple. So we'll try it with this one. We have this last number here. That last number, the c term, we're looking for 2 numbers that multiply to get that one. And those same 2 numbers have to add to get the middle term. Now remember, if this was not in order, so for example, 8x plus x squared plus 12, you'd have to put it in order in descending order so that you know which term is the b term and the c. So the product number is positive 12, and the sum we're trying to add to get 8. So I'll give you a second, click pause, and try and think of 2 numbers that multiply to get 12 and add to get positive 8. So always start with looking with the product number. And so 2 numbers that multiply are 3 and 4, 2 and 6, 1 and 12. And so since these are all positive, we have to multiply to get positive 12. And we're looking for a sum. If we have positive 2 times positive 6, that gets positive 12. And if you add those 2, you also get 8. So the integers are positive 2 and positive 6. So if in factored form, you do your skeleton, which is kind of like the blank, empty, no numbers in it. We put our integers plus 2 in the one bracket and plus 6. Now it becomes tricky when you have cases where you have to get, for example, a negative or a negative here. Now remember, one thing that people usually forget is this positive 12. I could have also done negative 2 times negative 6, and that still would have given that positive 12. And then if the number I was looking for was negative 8, this would work, because negative 2 times negative 6 is positive 12, and adding them is negative 8. But that's just another example. Continue on, we can do a couple more here. Let's try a trickier one. For example, try this one. So click pause, we'll try that one, and you can check your answer. So hopefully you came up with that product and that sum number. And so again, starting with the product number, 2 numbers that multiply to get negative 14, negative 2 and 7, negative 7 and 2, 1, 14, one of them being negative, and 1 and negative 14. And so looking at this, they have to add to get you negative 5. So the ones that add to get negative 5 are negative 7 and 2. And so our skeleton form is p, since that's the variable. And then we put in minus 7 and plus 2. Make sure you put that plus sign. Don't leave that out. So this one here is a little bit different. The only difference is that in your skeleton, where we would only have a first variable, now the front is going to be m and the end is going to be n. So m and n, and then your integer would go in between. So two numbers that multiply to get 16 and add to get -8. And this is one of those situations where we can multiply two negative numbers. Oh, so this one is -8 and this one is +16, where we can do -4 times -4, and we can also add those, and we would have what we're looking for. So it's 4 n bracket 4 minus n, m bracket 4 minus n. So try a couple of the other ones and you will be able to see those. And finally, here's two other examples that you could try. However, as you try them, I want you to make note that not all of these simple trinomials are factored with integers. So sometimes it might end up being that it was like x plus 2.135, and that's impossible for you to find out at this point. In later chapters, you will be able to figure that out. So if you can't, just remember that you do common factoring first, and then even once you've tried common factoring, it's possible that it may not factor. So if you have any questions, please make sure you write them down and bring them to class. Have fun!